Today we want to showcase all our spectral systems that we have in our department, all kinds of hyperspectral or spectrometers. We want to show them in action, to show you how we use them and to compare each result with each other's device. Let me briefly present you the systems that we want to use today. So here we have the DJI Mavic 3 multispectral, a multispectral drone with 4 channels. Then we have here the Mika Sense RedEdge-P, a multispectral sensor that we use on the DJI M350. With this device we are collecting also RGB data from the Zenmuse P1, as well as we fly our hyperspectral push broom sensor, the Nano Hyperspec HP. And here on the left side we have our mobile field spectrometer, the PSR 1100, where we do spot measurements with a hyperspectral device. Here the DJI Mavic 3 multispectral, or M3M how it's often called. It has a multispectral sensor fixed attached to the drone with 4 channels. It has a green, red, near and a red edge channel, and as well as an RGB camera. And this is the main advantage of this drone. It's easily built up, unfolded, and then you can, during one flight you have RGB data and multispectral data, so it's quite an efficient flight system. You can choose whether you want to fly only with RGB or whether you want to combine it with RGB and the near data as well. It's a low-cost system that's perfectly used for farmers that want to create application maps, biomass detection to analyze relative differences within a field for site-specific precision farming applications. So it's easily unfolded, it's a fast flight plan, efficient flight, and you have multispectral data from plant reflection to detect plant differences. Here in the back we have our diffuse light sensor that is measuring the incoming sunlight, or and today overcast light conditions. He's measuring the current situation and is comparing it to the reflection that we gather with the sensor in front of the drone. The flights are planned on the remote control directly with the fingers, or you can import existing field boundaries and you just tip and it's quite easily created in the field. Here we have the Mika Sense RedEdge-P. It's the most common widespread multispectral sensor currently in the market. It has 5 channels and a panchromatic RGB channel to do a panchromatic sharpening process and to get an improvement in the resolution of the multispectral channels of the other ones. You have RGB, red, green and blue as channels, and you also have a near channel and a red edge channel. So you can create the most common indices, the NDVI, the NDRE, and the GNDVI, for example. You attach it, in this case we have a Skyport connection to the drone, the DJI M350, so you can do the flight planning on the remote control of the drone, and the drone triggers the multispectral camera. Here we have also the Mika Sense calibration target. It's quite automated. We have a reflection gray standard, and here we have a QR code that is automatically recognized in a certain height when you hold the drone over the device. So you have calibration images prior to the flight and after to the flight. That is a recommendation. This is usually used in a research context or in agriculture context because it delivers high quality multispectral data from the most common channels that are used within this area. For the mounting on the DJI M350, you have here, it fits in the gimbal, and you mount here a DLS sensor also, where you can measure the current light illumination as the current conditions. That is still here in this box. Not really multispectral, but here we have an RGB sensor, the Zenmuse P1. It's a high resolution RGB camera. So also this is used in a research context when you want to get highly detailed images, to do machine learning on images, image detection, species recognition, this type of application where you need really good resolution. You go to the Zenmuse P1. For the camera you can choose between 3 lenses. You have the 24mm lens for a more brighter field of view, for efficient flight performing. And we have the 35mm lens where you can look even more in detail, and the 50mm lens The flight stripes get nearer, but you get a more, even better resolution. Here we have from Headwall Photonics a push broom scanner. This means he's capturing line by line. It's a hyperspectral push broom line scanner called the Headwall Nano. This delivers 270 channels. In the HP version, it even delivers 340 channels, spectral channels, so highly detailed spectral curve that you can detect with this device. It is used most commonly in the research context to detect specific bands that are relevant to your research question, in environmental monitoring, in infrastructure inspection, and in geology and mining and mineralogy to detect devices. In this case, it's sensitive in the region from 400 to 1000 nanometers, but you can also, in the co-aligned version, you can go from 400 to 2500 nanometers and have highly detailed spectral reflectance signal. Here we have a mobile field spectrometer, the PSR 1100. It's a vegetation mapper for the typical vegetation analysis and water quality estimation. It's a spectrometer, so it's measuring spots, but you have the highest spectral resolution with up to 2100 channels that you collect in the end. You strap it around and you measure it plot by plot, spot by spot, and you end up with a list of spectral measurements there. So here we have multispectral devices and hyperspectral devices. With multispectral devices, you can detect raw near-infrared data. You can see the plant reflection. You can detect differences, relative differences between biomasses within a field. This is mostly used in an agricultural context for biomass mapping on a field level. If you want to go into more detailed, in a research context or in specific questions, you need more spectral details, you want to look more closely, you choose hyperspectral scanners. After the work in the field is done, each of the system has its own post-processing procedure. These different sensors vary regarding processing speed, processing complexity, and the data size of the output result. What it boils down to in the end is with all of these sensors, you can differentiate them regarding spatial resolution, so what centimeter pixel size you want to have, or the spectral resolution, how detailed your spectra is supposed to be. Here we can see regarding the channel size with the Micasense RedEdge-P and the DJI M3M multispectral, you have quite broad channels, so quite a raw spectral signal. And here with the Headwall Nano and Spectral Evolution, you have a very detailed spectral, very quite specific color that you look in the near and in the visual range. Here in this graph you can see the differences in their spatial resolution. So you can see that the RGB images have the highest resolution, then usually come the multispectral sensors and the hyperspectral, and you have the lowest resolution of course with the spot measurement of the field spectrometer. Usually if you want to go for highly detailed images, you need to choose the RGB sensors. This graph shows the main differences between the sensors. You can here see the sensors with the highest spatial resolution, and on the other axis you can see the sensors with the highest spectral resolution. And you can see the best combination of those is the Headwall Nano. You get a good, reasonable spatial resolution and a very good detailed spectral signature, so a very good spectral resolution as well. With the field spectrometer, you have a low spatial resolution actually, because you only measure one spot, but you have the highest of possible spectral resolution with 2100 channels. That's why it's often used for ground truthing. They really need to calibrate your systems, and these systems are used. If you want to go for high spatial resolution, you choose RGB cameras. If you want to have a mix, have good spatial and at least some information regarding the near-infrared band, then you choose multispectral sensors. To put it all in a nutshell, all of these systems have their justification. Each of them has their advantages in certain questions. So if you're unsure what system fits your question the best, just give us a call or write us an email, get in touch with us, and we talk about it, what system fits your needs the best.